Hi, everybody. It's Miss Mac here. I'm going to talk to you today about correlation coefficients. They are something that you might see a little bit of on the air test. It's a pretty simple concept in terms of what they might ask. So we wanted to make sure to cover this with my video and a little bit of practice. You should know everything you need to know about these for the test. If you have any questions when you are done, please make sure you ask. So we're going to start out talking about correlations in general. And a correlation is just a relationship. So whenever you see the word correlation, think, oh, I'm looking for a relationship between two things. And because we're dealing with algebra, we are going to be dealing with relationships between two quantities or variables. All right. And so what we're going to do is we're going to kind of describe in general what these correlations are or what they look like and how you know what they are. And then we're going to talk about how we label them. So the first correlation that we're going to talk about is a positive correlation. And a positive correlation is when the values or the variables increase together. So if you look right here on the first example, we have the height of a person and the weight of a person. Remember, going to the right is getting bigger and going up is getting bigger when we talk about graphs. So basically this means as our height gets more, as a person gets taller, the weight of that person also gets taller. And notice, as if I start here, I have this height and I have this weight. But if I go further to the right, I go further up on the y. So as I'm going to the right, I'm also going up, and it's creating kind of this pattern here. So height increases is followed by a weight that increases. So both are increasing. And that's what we call a positive correlation. They're both increasing together. Now, the next one we're going to talk about is a negative correlation. And that's when one value or variable decreases as the other one increases. So if we take a look at this example down here, the speed of a train and the length of the time to get to destination. Again, going to the right is getting bigger and going up is getting bigger. So I know if my speed of my train, if my train's going this fast, it takes this long to get to its destination. But as I get going faster, it takes less time. Notice I'm going up less high on that axis. So if I come down here and I'm going this fast, it only takes this long to get to my destination. So basically, as my speed is increasing, going to the right, my length of the time to travel is decreasing. And if you notice, this has a negative slope. As one thing is increasing, the other is decreasing. The top one had a positive slope, the bottom one had a negative slope. Now, those are two types of correlation. It's also possible that there's absolutely no correlation, and we're going to look at that in the next example. So this has three problems. Determine if each pair of variables has a positive, negative, or no correlation. So we're just going to look at this and we're going to decide for each one what we think. So the first one said the outside temperature and the number of ice creams bought. So this is kind of our first thing, the outside temperature. And I want to know, is there a correlation with the number of ice cream cones bought? Well, if you think about it, and I draw this, as my temperature gets higher as it goes to the right, my number of ice cream cones bought or sold, I guess either one, would probably tend to go up because people think of ice cream when it's warm, unless you're Mrs. Richard and you think of ice cream all the time. But as the temperature goes up, my number of ice cream cones go up. So if I start out with a low temperature, I probably am not selling much ice cream. But if I go down here to a higher temperature, I'm probably selling more. And here, there's more. So as the temperature goes up, the ice cream cones go up. And because that's a positive slope, that's a positive correlation. The next one we're going to do is the height of a person and the score on their math test. So we want to know, is there a relationship between a person's height and the score they get on the math test? So if I think about it this way, here's my height and here's my score. So I want to know, does it matter as I get taller? Does that mean my score on my test is going up? Or does it even mean that the score on my test is going down? I'm going to say it's going to mean neither, because it does not matter how tall I am, it is not going to affect the score that I get on a test. A graph like this probably has no pattern to it at all. It's just kind of all over the place. We call that no correlation. The last problem that we're going to look at, let's pick a different color. Let's pick that blue. Okay, age of a minivan and the value of the minivan. So if I look at this, this is the age and this is the value. So if you think about it, when you first get a minivan and you have it, it's not very old, its value is high. But the older it gets, the less expensive it is, or the less value it has. And it may not be in a straight line, but we know that basically this is going to decrease with age. Because it's decreasing with age, we say that that has a negative correlation. So you've got to relate the two variables and see what kind of a relationship there is. Okay, so now match each graph with the correct pair of variables. So I'm going to start by looking at the graphs down at the bottom, and I am going to notice that this first one, A, tends to have a positive correlation. It's not perfect, but in general, there's kind of a positive, an increase, it's going up. In this second one, it's kind of a negative correlation. It's kind of going down. It's not great because you can see it's still kind of all over the place, but it's going down from left to right. And this last one looks like there's no correlation because literally that's just a bunch of points all over the place with no pattern. So if we go back up here and we look and we try to match these, number one says the number of hours worked and the amount of money in your paycheck. So if we think about it, the number of hours you work, as you work more, the amount of money in your paycheck should be more. So it should be an increase that goes with an increase. And an increase with an increase is a positive correlation. So that should be A. The next one that we're talking about, the number of pets a person has and the number of books that they read. So if my number of pets increases, does that have anything to do with how many books you read? No, there is no relationship there at all. So that's going to be a C. There is no correlation. And the last one, the distance traveled and the amount of gas that's left in the car. So the amount of distance you travel, if that increases, if you think you travel more in your car, the amount of gas that you have left decreases because you're using gas and the amount is going down. So an increase followed by a decrease is a negative correlation. So that would be B. All right. Now, here's that. The first part is kind of understanding what correlation means. This part is how we represent it mathematically. So we have this thing called the correlation coefficient, and we use the variable R to stand for that. R does two things. It measures the strength of the relationship, so it's a strength of a relationship, and the value ranges from -1 to 1. So we'll kind of talk about what that means. So if you ever see a value of R, it's got to be some number between -1 and 1, and it could actually be -1 and 1. So if you look down here, I kind of have a continuum drawn, starting at -1 here on the left, and notice that is what we call a perfect negative correlation. That is almost perfectly a straight line going down, everything's lined up with a negative slope. On the far right, we have a perfect positive correlation of +1. Notice those dots are just about perfectly in a straight line with a positive slope. Now, in the middle, we have 0. 0 means no correlation at all. That's that scatter plot where there's no relationship. It does not matter how many pets you have and what your score on your math test is going to be. That would be a no correlation. Now, everywhere between there, we can have some decimal. I'm going to start on the right side. So if I look at this one, 0.5, and this is 0.9. Well, 0.9 is closer to 1, so you would expect those dots to be closer to a perfectly straight line. 0.5 would be more spread out, but still represented by a positive slope in a straight line. The points are just a little bit further away from the line. If I look to the negatives, negative 0.5 is definitely decreasing, but the points are a little bit farther away from the line. They're not so much perfectly straight. And if I see a negative 0.9, they're a lot stronger. It's closer to a straight line, but it's not perfect. And then, of course, the numbers can be anywhere in between there. You can have any number. I could have a positive 0.1. I could have a positive 0.62. I could have a negative 0.73. I can have any number in between there, but just know that the closer they are to 1 or the closer they are to negative 1, that is perfect. So basically, here's what you need to know here. Let me switch to an orange. Okay, so basically these ends out here are where the strong correlations are. It can be strong positive and it can be strong negative. Strong means it's almost in a straight line. In the middle, there is no correlation at all. And then I know if I'm starting with no correlation here, as I go this direction, it's weak here and it gets strongest out towards 1. And likewise to the left, it is weakest in here close to 0 and it's getting stronger out here closer to negative 1. Okay? So the next question says the numbers below are all correlation coefficients. Circle the strongest correlation coefficient in orange and box the weakest one in green. So if you take a look at these numbers, now you have to remember it gets confusing. People think positive and negative, but what we're looking for, the strongest correlation is going to be the number that is strongest is going to be closest to negative 1 or positive 1. And if I look down here at all these numbers and I look for the one that's going to be closest to negative 1 or positive 1, this right here is the one. That's closer to negative 1 than this one is. This one is close to 1, but it's not quite as close as this one is to negative 1. So I know my strongest correlation coefficient is this negative 0.81 because it's the closest to one of the ends. Now, the weakest correlation coefficient, the one that I'm going to put a box around, is the number that is very closest to 0. It does not matter if it's positive or negative. It needs to be closest to 0. And of all of these numbers, that's this one right here. So that would be my weakest correlation coefficient. And that's what you need to know about these. You have a few problems to practice in Schoology. Make sure you ask for help if you need it. Thanks, guys. Good luck.